Just give me a minute, ma'am. I'll set my mic.
Isn't am I audible?
Yes, ma'am.
Yeah. Can you turn on your camera?
Yeah, just a minute. I
Good. So in yesterday's class, I mean in the last class, we have discussed mainly about the mole concepts, right? And percentage composition, empirical formula, etc., etc. And lastly, I have discussed about the stoichiometry part also. So let me just go through the stoichiometry once, and then I'll continue with that stoichiometry calculations. Okay.
yeah.
So the learning objectives are these two: stoichiometry and stoichiometry calculation and limiting reagent under this topic. So in last class itself, we have discussed about this. So what is stoichiometry? It is the quantitative analysis of a balanced chemical reaction. Okay, and also we have taken the burning of methane as an example. Okay, and the stoichiometric observations are in terms of moles. How do we say this? 1 mole of methane reacts with 2 mole of oxygen to give 1 mole of carbon dioxide and 2 mole of water. In terms of molecule, how do you represent this in terms of molecule? Again, the same thing, right? Yeah,
Yeah.
one molecule reacts with 2 molecules to give the corresponding compounds. And in terms of grams, how do you represent this? How many grams of methane is reacting with oxygen?
Uh, 16 grams.
Yeah, 16 grams of methane is reacting with
Uh,
16
32
grams.
into 2,
Yeah, very good. And to give
64
46
grams.
grams of carbon dioxide and 2 into 18, 36 gram of water. Okay,
Yeah,
so this is what we have discussed. And also, I have given you one question, right? We have solved this question, right? In the last class. Did you get
yeah,
the
this one.
answer? Yeah.
108 grams of water.
Okay, fine. So we were asked to find out the amount of water. So first of all, for any calculation, any stoichiometry calculation, we need to take the balanced equation. Okay, if the equation is not balanced, we just balance it. And here from this equation, 16 gram is producing 36 gram of water. So therefore, 48 gram will produce 108 gram of water. Okay, so this was the question we have discussed at last. So now I am going to give you one more question from this topic. And then later on, we are going to move on to the next. So here is the question. Calculate the amount of carbon dioxide that could be produced when 2 mole of carbon is burnt in air. Calculate the amount of carbon dioxide produced that could be produced when 2 moles of carbon is burnt in air. How to approach? So here 1 mole of carbon is burnt in air. Air in the sense, so we are burning the carbon in presence of oxygen. Air contains oxygen, right? So this is the reaction with carbon in presence of air, which is nothing but oxygen. So 1 mole of carbon is producing 1 mole of carbon dioxide. Can you able to understand this? So here we have only 1 mole, right? Here we
Yeah.
have one carbon and it is producing 1 carbon dioxide. So they are asking us to find out the amount of carbon dioxide produced for 2 moles of carbon. So what to do for that? Can you?
Uh, like maybe I can write 1 mole of carbon produces 1 mole of CO2. carbon dioxide. So
Yeah.
2 moles is how much? Like that.
I mean, they are asking us in terms of amount, right? Amount means you have to represent the answer in terms of grams. Okay.
Grams.
So here 1 mole is reacting and it is producing 1 mole of carbon dioxide. So this is in terms of moles. In terms of grams, 1 mole means how many grams of carbon dioxide is being produced?
12 plus
Hmm.
32. 64.
64.
Yeah. So it'll be 88.
64. Just check
Six,
your addition part. 12 plus 32.
12 plus 32 into 2 because, yeah, 12 plus 32. Yeah.
Why 32
It'll be
into?
44.
Yeah. So 1 mole of carbon is producing 44 gram of carbon dioxide. Okay. So therefore, 2 moles will produce how much?
44 into 2.
That's all. So for 44 into 2, so which is nothing but 88 gram of carbon dioxide. Okay. So if the question is asked in terms of amount, then it is meaning that we have to find out the answer in terms of grams. Got it? Clear?
Yeah, and I note down this one. So it'll be like easy for me.
Sorry?
I
Your
will
what?
note it down.
Yeah, yeah, sure, sure. Let me know once you are done with it.
Yeah.
Fine. Just a moment. So you can able to see the screen, right?
Yeah.
Yeah. So the next topic is the limiting reagent. So what is limiting reagent? So the reactant which gets consumed first and limits the amount of product formed is called as limiting reagent. So what do you understand from the statement? We may have two reactants. Okay. For example, I'm saying we may have two reactants. The one which is getting consumed first, the one which is getting reacted first, or the one which is present in very lesser amount in the reactant part is called as limiting reagent. Limiting means it will stop the reaction. Okay. So if a reactant A is the amount of A is 50 gram, then if the amount of B is 30 gram, then the 30 gram will get consumed first, right? So we will not have remaining 20 gram of B to get reacted with A. So what happens in that point? At that point, the reaction gets stopped. Okay, so the B is the limiting reagent over there. So that limits the reaction. That stops the reaction. The one which is present in very lesser amount is called as limiting reagent. Got it? Now we can able to understand, right?
Yeah.
I will give you some examples. So the example which I have given now is for 1 mole of A and 1 mole of B. If some other stoichiometric coefficients are given for A or B means, then we have to follow some steps. Okay. So I'm going to give you those methods now. The method to solve problems based on limiting reagent. So step number 1. So first of all, again, you need to take the balanced chemical equation. Okay. And step number 2 is calculate the moles. You know how to calculate the moles, right? What is the formula to find out the number of moles? What is the
Uh,
to find out the number of moles?
Given moles by number of moles.
Given mass, the
Given
given,
mass by num. Yeah.
yeah, the given mass divided by molar mass.
Molar
Okay,
mass.
the formula. So using this formula, you are going to calculate the number of moles. That is step number 2. Then step number 3 is we have to calculate the ratio of number of moles to the stoichiometric coefficient. So I told you, no, we will have minimum we'll be having 2 reactant. So we have to find out the ratio of the number of moles of both the reactant. Okay, to the stoichiometric coefficient. Then the compound with minimum ratio will be the limiting reagent. This is the very important part. The compound with minimum ratio will be the limiting reagent. And after doing these 3 steps, you have to finally do all calculations based on the availability of the limiting reagent. Okay. So the fourth
Yeah.
step is according to the question. So whatever they are asking, according to that, we will proceed with that. Okay. So the first 3 steps are mandatory. What we are going to do? Balance the equation, find out the number of moles for both the reactants, then take the ratio to the number of moles. With the stoichiometric coefficient, you will get the answer. Okay. So we will apply these steps to the problems or to the numerical problems so that you can understand better. Just note down the steps alone here with the definition. So this is the definition for limiting reagent. You want to take this down?
Yeah. No.
Yeah, take it.
Yeah.
Okay. So let's do one question. So here is it. 50 kilogram of nitrogen and 10 kilogram of hydrogen are mixed to produce ammonia, NH3. Calculate the amount of NH3 formed and identify the limiting reagent in the production of NH3 in this situation. So what we are asked to find out? First, we need to find out the amount of NH3 formed. Then we have to identify the limiting reagent. Okay, so two things we have to calculate. And the equation is also given. Got it? So shall we apply all the steps what we have which we have studied before? So
Yeah.
let's take the equation. So step one is you have to take the
Balance.
reaction. So how to balance it? N2 plus 3H2 will give 2NH3. Okay. So
Yeah.
in NH3 we have 3 hydrogen. Okay. You have to put 3 here and 2 here. Then only 3 into 2 will become 6 and here 2 into 3 will become 6. Hydrogen will get balanced. Okay. And if you put 2 here, automatically the nitrogen is going to get balanced. So the equation is balanced. Okay. So we have balanced this. This is one of the very important reaction which we will be using in many examples. Okay. Many reactions, many problems, and many lessons you will use this reaction. So you can memorize also. Okay. N2 plus 3H2 giving 2NH3. Okay. Then what is step number 2? We need to find out the number of moles of each compound. Okay. So what is the formula again? Given mass divided by molar mass.
Volumes.
Yeah, what is the given mass of nitrogen? Do you remember? How many grams of nitrogen? So it was given
14
in the question. No, no. Given mass. The given mass was 50 kilogram. It was given in the question.
in the
And for
question. Yeah.
nitrogen, how many gram we have seen? It was 10. So these two informations are given in the question. So now to find out the number of moles of nitrogen, what you need to do? Given mass
Given
of
mass by molar mass.
divided by molar mass. So the given mass is here. What is the molar mass of nitrogen?
It is 14 plus 14, so it will be 28.
28. Good. So what we need to do? 50 divided by 28. Okay. So it is going to give you 17.86 into 10 power 2 mole. Okay. So in the same way, find out for hydrogen also. So the given mass of hydrogen is 10.
6. 10 by 6.
10 by 6 you need to take. What you will
Yeah.
take? You have
Its
to
mass
take
is 1,
the
right? So
molar
6.
mass of only one hydrogen. Okay. So just
Only one hydrogen.
yeah, one hydrogen you have to take.
Then
So
for nitrogen, why do we take 28? It should be 14, right? 1
yeah, here
and 2.
for
Yeah.
one just one and for two hydrogen, one plus one, two.
Yeah, 2. So
Got
I
it?
thought we should multiply 3 into 2, 6.
No,
So
that we should not do. Molar mass means it is for one mole, right? So in the last class we have studied that only for the definition of molar mass. So the atomic mass of hydrogen is 1.008 and for molecule you need to multiply this by 2 and you will get 2.016. You can take 2 also, no issues. Okay, 10 divided by 2 also you can do and you will be getting the answer in terms of 5 into 10 to the power 3 mole. So no issue with that. Got it? And why we
yeah.
are getting this 10 power 3 here?
Yeah, just give me a minute.
Okay.
Yeah, actually, there is a lot of disturbance going on back, so that's I.
Okay, okay. Fine. So what we have been discussing, I was asking you about the 10 power 3 term over there. So why we are using this 10 power 3 here?
Uh, because it is like it is thousand, right?
Yeah, here you have to see the units. The mass is given in terms of kilogram, but the molar mass we are representing in terms of gram. Okay, got it? So to convert this gram and kilogram into gram, we are using that number. Okay, so that's why we are getting that. And step number 3 is you need to find out the ratio, number of moles versus stoichiometric coefficient ratio we need to take. So we have two reactants, one is nitrogen and the other one is hydrogen. And the number of moles for nitrogen is 17.86 into 10 power 2. And the stoichiometric coefficient for nitrogen is how much? What is the stoichiometric coefficient? It is
The
1.
number 3 and 2,
No, for
3 2
nitrogen.
for
For
hydrogen
nitrogen,
1.
it is 1. So just divide the moles by 1. And the same way
Same.
for hydrogen also. Number of moles of hydrogen divided by the stoichiometric coefficient of hydrogen, which is 3. And if you divide these two, what you will get? In terms of 10 to the power 3, we are getting 1.7 for nitrogen and 1.6 for hydrogen. So now you tell me which is present in very greater amount. Nitrogen is present in very greater amount, right? 1.7 is the
Yeah,
bigger number compared to 1.6. So nitrogen is higher here. So the one which is present in very lesser amount is hydrogen. So
hydrogen.
hydrogen is the limiting reagent. Okay. So we
Yeah,
have got the limiting reagent. But we were asked to find out two things. No, only one we have got it. Limiting reagent, the remaining amount we have to find out in the next step only. So do you want to copy this?
yeah, I want to copy. So like when I like divide 50 by 28, so I should like write the answer in form of like this equation here, or I can write in fraction form also.
Fraction in the sense, what you are asking?
In this one, like you wrote right, moles of nitrogen is equals to 50 by 28. Yeah, so like
Only if you get the answer in terms of this decimal like this, you can able to get the limiting reagent, right?
yeah, yeah,
Okay. The power should be same, then only you can equate, right? So that's why we have moved this decimal also here. If the powers are not going to be same, then you cannot equate this, right? 1.7 and 1.6. It will give you the wrong answer.
Yeah. May I see the question? I wrote this all the answers.
Sorry, you need the question?
Yeah. Yeah.
Okay. So the second subdivision is we need to find out the amount of NH3, right?
Yeah.
So calculations based on availability of the limiting reagent. So now how many moles of hydrogen we have? 3 moles. So 3 moles of, from the given equation, 3 moles of hydrogen produces 2 moles of ammonia, right?
Yeah.
N2 H2 gives 2 NH3. So therefore, how many moles of hydrogen we have calculated in the previous slide? How many moles of hydrogen we have in the given question?
Three.
4.
One.
No, no. I'm asking the number of moles of hydrogen we have calculated in the question. It is 4.96 into
Nine
10 to
six.
the power
Yeah.
3 moles of hydrogen, right? So that many mole of hydrogen will produce, just cross multiply. 4.96 into 10 to the power 3 into 2 divided by 3. Okay? So
Yeah.
give you 3.30 into 10 to the power 3 mole of NH3. So now we have calculated the number of moles of NH3 produced. But our aim is to find out the amount of NH3 produced, right? So what is the aim? We need to find out the amount. Amount means mass. What is amount? It is mass. So mass of NH3 produced, you need to find out. So how will you find out the mass of NH3 from the moles of NH3? From the same
Uh,
formula only. So we know number of moles is equal to the given mass divided by molar mass. Now to find out the mass of NH3 or the amount of NH3, just take this to the other side. Number of moles into molar mass of NH3. Got it?
yeah.
So the mass of NH3 obtained is equal to number of moles of NH3 into molar mass of NH3. So we have both the things. So just substitute the values and you know how to calculate the molar mass for NH3, right?
Yeah.
For nitrogen it is 14.
14.
Hydrogen it is 1. We have 3 hydrogen. So it is 3. So 14 plus 3
17.
is 17. So that's what we have substituted. Then you multiply these two and you will get 56.1 into 10 to the power 3 gram. And if you want to represent this in terms of kilogram, because in the question we were provided with the amount of hydrogen and nitrogen in terms of kilogram only, right? Like
Yeah.
50 kilogram of nitrogen and 10 kilogram of hydrogen. So you can represent the amount of NH3 also in terms of kilogram. It is very easy. It is already in terms of 10 to the power 3. So just convert it. 56.1 kilogram. 56.1 kilogram of NH3 is being produced from the given information. Got it?
Yeah. Yeah.
Don't just copy the problem. Copy, understand, and then copy. Okay? So you need to know what we are doing.
Yeah.
Finished?
No, I'm
Okay. Right.
Yeah.
Okay. So let's do one more question. Are you ready to solve one more question from this?
Yeah.
Yeah. There is a question. Chlorine is prepared in the laboratory by treating manganese dioxide with the aqueous hydrochloric acid according to the reaction. So chlorine we are getting in the laboratory by mixing these two reactions. Okay. So equation is also given to you in the question. Now find out how many grams of chlorine is produced if 10.95 gram of HCl reacts with 8.7 gram of manganese dioxide. So we do not know which is the limiting reagent. Okay. So first of all, we need to find out the limiting reagent. So to find out that, we need to follow the first three steps. Then only we can get the grams of chlorine. Okay. So this question is similar to the previous question. So we are asked to find out the grams. Grams in the sense the amount of chlorine produced. Okay. So in the previous question, we have got nitrogen and hydrogen with the 50 kilogram and 10 kilogram values. And here also we are provided with the values in terms of grams. And we are asked to find out for chlorine. Okay. So the same way we are going to proceed. Just take down the question. Now itself, we'll proceed.
Yeah.
Okay, so let's proceed. What is the first step? Take the balanced reaction. Reaction is already balanced, right?
Yeah, it's already balanced.
So now find out the number of moles of each component. How to find out? For each component means for the reactants. So we have two reactants. Find out the number of moles of HCl first and then go for manganese dioxide.
Yeah.
Yeah. So what is the number of moles of HCl?
It'll be given mass by molar mass. In the question, like the mass isn't given.
The mass of HCl is 10.97, right? 97 or 98. So just look into the question. How much it is? 10 point?
Yeah, it's produced, yeah, 10.95 grams of HCl.
10.95 is the atomic mass, sorry, given mass of HCl. And what is the molar mass of HCl? How to find out? For
One
hydrogen it is 1. And for chlorine it is how much?
35.5.
35.5. 35.5. So that is going to give you 36.5. So 10.95 divided by 36.5 will give you the value. You don't have to convert from kilogram to gram and all because the question itself we have the values in terms of gram only. Just divide, you will get one value. So that will be 0.3 mole. That will be 0.3 mole. Okay, for HCl. Don't have to consider this 4 and all. In the last question itself, I told you, no, don't consider this 4 to find out the number of moles. Then to find out the number of moles of manganese dioxide, what is the given mass of manganese dioxide?
Given mass is 8.7 grams.
8.7 divided by molar mass of manganese dioxide. For oxygen, you know how to calculate. For oxygen, it will be 30, 16 plus 16 is 32
32.
for 2 oxygen. And we have for manganese. For manganese, the atomic mass is 54.9.
Manganese.
Yeah, 54.9.
So it's 56 around.
54.9 will be 56 we are getting. 80,
86 point.
can approximate this. So it will be 87. So for manganese dioxide, it is going to be 87. So 8.7 divided by 87 is equal to how much?
8.7.
Divided by 87 moles.
0.1.
Very good. So it is going to be 0.1. Okay. So we have got the number of moles for both the components. Now what is the third step?
Uh, a ratio of like moles and the coefficients.
What is the third step? Number of moles versus stoichiometry coefficient ratio. So what we need to do for HCl, what you need to do? 0
Uh,
point divided by 4, right? For
yeah,
HCl, 0.3 divided by 4. And
good.
for dioxide, 0.1 divided by how much?
1.
What is the
1.
stoichiometric coefficient of manganese dioxide? It is 1. So it is 0.1 divided by 1. So by doing so, what you will get? 0.3 divided by 4 is 0.07.
0.6.
And here you are going to get 0.1. So which is greater? HCl,
Uh,
manganese dioxide.
Manganese dioxide is greater.
Yeah. So the one which is present in very lesser amount is nothing but HCl. So hence HCl is the limiting reagent. Okay.
Yeah.
So we have got the HCl as the limiting reagent. Now, with respect to this availability of this HCl, you are going to get the amount of chlorine produced. Okay. So that was the question now. You have to find out the limiting reagent and you need to get the amount of chlorine produced.
Yeah.
So you have to Calculate the amount of chlorine based on the availability of HCl because we have found out that HCl is the limiting ingredient. Are you getting?
Yeah.
Yeah. Just note down it fast. We'll calculate. So 4 moles of HCl is producing 1 mole of Cl2. So 0.075 mole of HCl will produce how many moles of chlorine? We'll calculate.
Yeah, sorry.
Okay, we'll calculate. We'll calculate. Just copy this down. Write it fast.
Yeah.
Okay. So step number 4 is calculations based on availability of limiting reagent. So 4 mole is producing 1 mole of Cl2. Therefore, 0.3 will produce 0.3 into 1 divided by 4 mole of Cl2, which is 0.075 mole of Cl2. Okay. So to
Yeah.
find out the mass of Cl2 obtained, what you need to do? What is the formula? To find out the mass of Cl2, it is number of moles of Cl2 into molar mass of Cl2. So what is the number of moles? 0.075. And the molar masses, how will you find out the molar mass of Cl2? So for 1 chlorine, it is 35.5. And for 2 chlorine, it will be 35.5 into 2. So what is
7,
35.5
80.
into 2? So it is, how much it is?
80.
80?
Yeah. 35 will be 70. And point five is nothing but 1. So it's 80.
It is 71, right?
30.
Yeah. Are you getting?
Yeah. 0.
71 gram. 71 gram per mole. So
Yeah.
just
71.
multiply these two and you will get a 5.325 gram as the answer. Mass of chlorine obtained. Okay? Clear?
Yeah.
If you are getting the limiting reagent as M and O2, then you have to proceed the fourth step with the number of moles of M and O2.
Yeah.
Okay? To find out the mass, to find out the moles, the first step is finding out the limiting reagent from the first 3 steps.
Yeah, yeah.
So that's all about limiting reagent. So these are the things we have discussed. Okay, stoichiometry and observation, and the method to determine the limiting reagent and the mass calculation from the limiting reagent. Okay. So do you have any doubt from the limiting reagent part which we have discussed today?
No, I understood.
Oh, great. So the last topic of this lesson is reactions in solution. This is the very last topic of this lesson. Okay. Reactions in solution. The learning objectives under this topic are, first we are going to discuss about the introduction to solutions. Then we will discuss the concentration terms, and those concentration terms are mass percentage and mole fraction. Third is molarity, and the fourth is molality. Okay. So with this, the lesson gets over. Shall we go with the introduction to solutions?
Yeah, like before proceeding, like is the stoichiometry over like here or still it's there?
Sorry,
Stoichiometry topic, is it over or
documentary topic is over.
like nothing else? Like this is all.
Yeah, I told you what is stoichiometry and how to do the stoichiometric calculations. That's all. You need to solve more number of questions. This is the concept.
Yeah,
Got it? You want to ask anything?
yeah, like for empirical formula and
Empirical and molecular formula calculations we have already completed no, in the last class.
yeah, we have.
So that is different topic. Empirical and molecular formula is different topic, and stoichiometric calculation is different.
Yeah.
Clear? Everything is clear?
Yes.
Okay. Now the topic is reactions and solutions. So only if you can able to understand the stoichiometry part and the empirical molecular formula part and the limiting reagent part, you can able to understand these topics. Okay, so that's why those topics are given in the beginning. So let's do the introduction to solution first. Then we'll move on to the remaining topics. Now, introduction to the world of solutions. What are or what is a solution? Any idea? What are
Uh, yeah, solution. A solution is something in which the solute dissolves, solvent dissolves.
okay? So the definition is a solution is a homogeneous mixture of two or more substances. Okay, it is a homogeneous. So what is meant by homogeneous mixture?
Similar.
Homo means it is same. Homogeneous mixture means so those two substances or more than two substances they are getting mixed completely. Okay, in the solution. So those solutions are called as homogeneous solution.
Yeah.
And the solution may exist in any phase. Any phase in the sense it can be in the phase of cold drinks. Cold drinks means it now here it is in the phase of liquid. Okay, it can be a solid also. Here you can take bronze as an example. Okay, bronze is a solid. And it can be in the form of gas also. Example is air. So it can be, solution may exist in any phase. It can be a liquid or it can be a solid or it can be a gas. Got
Yeah.
it? Clear?
Yeah.
So if you want to take down the definition, you can take this. I'll move on to the next slide. We have one more lesson named solutions in class 12. Okay. So in that lesson, we will continue this. So this is the introductory part of the solution. In that lesson, we will continue this. So these two lessons are interlinked. Both are physical chemistry and these two lessons are interlinked.
Yeah.
Okay. Now, solute is the substance which is to be dissolved. Okay. And the solvent is the substance which dissolve other substances. Can you able to understand the difference between these two?
Yeah.
The substance which is going to get dissolved is solute, and the one which is dissolving that solute is called as solvent.
So,
Okay. So mostly, if you look into the solute will be present in very lesser amount, okay, and solvent will be present in very greater amount. Solute is in lesser amount and solvent will be present in greater amount. Okay. Now
yeah.
the solute is present in smaller amount than solvent. That's what I have said now. And the solution is equal to solute plus solvent. Solute plus solvent will give you the solution. Got it?
Yeah.
So let's see some examples. Shall I proceed with the next slide?
Yeah, just a minute. Yeah, there is a power cut, so I have to like
Have the- Shall I continue with
yeah,
the
I have written it.
sorry, Susan, you are not audible. What you have said?
Yeah, I have written it. You
You have
can.
written, okay. So the examples to solutions are ground coffee and water, which will give you the drinking coffee. So here, which one is the solute?
Uh, it's solute. It's ground coffee.
Yeah. So water is a solvent and it is giving the solution. And the next example is salt plus water, which is giving the salty water. So again, the solute is a salt and the water is a solvent. And coming to the third
Yeah.
example, copper sulfate and water. The copper sulfate is the solute and water is the solvent, which is leading to
Yeah.
the copper sulfate solution. Okay, these are just the examples, very easy examples. So the next topic which I'm going to move is the mass percentage and mole fraction. Shall I proceed?
Yeah, you can.
So before moving on to that, I just want to introduce a term called concentration. This is very important. Okay,
Yeah.
I'm having a beaker and I have a solution inside that beaker. Now, the quantity of solute present in a given quantity of solution is called as concentration. The
Yeah.
quantity of solute present in a given quantity of solution. So, this is the solution. The quantity means the amount of the solute present in given quantity of solution is called as concentration. So, the other name for concentration is strength. We can also call this concentration as strength. Concentration of the solution can be called the strength of the solution. So strength can be measured in many ways, right? Strength of the solution can be measured in many ways. So the first way is using mass percentage. The second way is mole fraction. Third is using molarity. Fourth is using molality. So these are some of the ways in which the strength of the solution or concentration of the solution can be measured. mass percentage. So what is this mass percent or mass percentage? So first I'll give you the formula, then I'll explain you with some examples. So mass percent is equal to mass of solute divided by mass of solution into 100. Okay, so this is the formula which is very important. Okay, you will be using this formula to solve all the numericals, which is going to get asked from this part. Okay, so I'll take a question and then I will explain you this. We'll take one question. A solution is prepared by adding 2 gram of a substance A to 18 gram of water. Calculate the mass percent of the solute. So here we have two components. Who are those two components? One is substance A and the other one is water. Now substance A means that is the solute, right? Substance A is called as solute. And we
So
all know water is the solvent. So we have the mass of solute and the mass of solvent with us, and we have to find out the mass percent using this information. Very easy, right? How will you do?
yeah,
Mass of the solute is 2 gram and the mass of the solution we need. So how will you find out the mass of solution? Just add solute and solvent mass. Mass of substance A and mass of the solvent
20.
water will give you the mass of solution. So what is going to be the answer? 2
20.
18. Yeah, the answer is 20. Now what do you have to do? Substitute in the mass percent formula. 2 divided by 20 into 100 will give you 10 percentage. Okay,
Yeah,
so 0, 0, 2, 2 gets cancelled and it will give you 10 percentage. Okay, 10 percentage of the substance A is present in the solution.
yeah,
And that is the meaning. The amount of solute present in the solution is called as concentration, and in terms of mass percent, this is the meaning. Clear?
yeah. Yeah, and this is the first formula of this topic, right? Solute,
Sorry,
solvent, and
little bit
uh, th-
loud.
this is the first formula of solute, solvent, and solution, right?
Yeah, we have more than 4 concentration terms. Okay. So here in this lesson, I mean in this class 11 first lesson, we'll be studying only 4. And among those 4, this is the first formula. Okay.
Yeah,
According to the given information, you have to proceed with the corresponding formulas. Okay, here we are provided with grams and we are asked to find out the mass percent. So we are using this formula. And if you are asked to find out the concentration in some other terms, then you will be using that particular formula, which I will be teaching you in upcoming
yeah,
slides. Okay?
yeah.
Yeah. Shall I go with the next term?
Oh, yeah, one almost over the solution.
Okay, okay.
Yeah, yes, you can.
Mole fraction. So what is mole fraction? It is the ratio of number of moles of a particular component to the total number of moles of the solution. Number of moles of that particular component divided by the total number of moles of the solution. Okay, it is represented by chi. So this symbol is called as chi. Okay, you have to write like this. Like X you have to write. It is actually called as chi. So the mole fraction of chi is equal to number of moles of that component divided by total number of moles. So this is the formula. This is the definition. You can take either this formula or the definition. Both are same only. Okay.
Yeah.
Finished?
No.
Completed?
Yeah, almost. Yeah.
Okay. So here you are seeing one picture, right? So we have two components. One is A and the other one is B. Okay.
Yeah.
Now, if I want to find out the number of moles of A alone, then how the formula will become like, so chi A is equal to number of moles of A divided by the total number of moles, which is
Yeah.
Na divided by Na plus Nb. Are you getting?
Yes.
Yeah, very easy formula. Now tell me the formula to find out the number of moles of B. I mean the mole fraction of B. How to find out chi B?
Number of moles of B by
Total number
number
of
of moles of solution. So N B by N B plus N B A.
Nb divided by Na plus Nb. That's all. Okay, I may have more than two component also. I may have a component C. So in that case, what I have to do to find out the mole fraction of A? It is Na divided by Na plus Nb plus Nc. So if I'm
And
having the third component C, then I have to include that also. Getting the number of
yeah.
moles of that component divided by the total number of moles. So that will give you the mole fraction. Very easy formula. And here you need to note one thing. The sum of mole fraction of all the compounds present in the solution is unity. Means here I have two components, okay, A and B. If I sum up the chi A plus chi B plus chi C, that will be equal to 1. Okay.
One. Yeah.
So you don't have to calculate the mole fraction for A, B, C, D, etc. Got it? So if you are getting the value of chi A, then you can get the chi B using 1 minus chi A formula. Are you getting my point?
Yeah.
So you just substitute the value of chi. Suppose if chi A is equal to something around 0.097, then you can just subtract these two numbers and get the value for chi B. You don't have to substitute here and do the addition, multiplication, division part again. Okay, for the time consuming, it is a time consuming thing. You don't have to do for each and everything. Just use this formula and get the answer. Okay, shall we do one question based on the mole fraction formula?
Yeah. Let me note down this.
Sorry.
Yeah, I'll write down this.
Okay, okay. Just write the formula alone. You don't have to write number of moles of A by 2. Just write phi A is equal to Na by Na plus Nb. Phi B is equal to Nb by Na plus Nb. And phi A plus phi B will be equal to 1. So just write the formula alone. It is
Yeah,
understood.
those are them.
Finished?
Yeah.
Okay. So here is a question. If 4 moles of alcohol and 6 moles of water are mixed, then calculate the mole fraction of each component. So we have two components, alcohol and water. You can take alcohol as A and water as B. So how will you proceed with this?
Psi A by psi A plus B.
Yeah, chi. It is not psi, it is chi. or else you use the letter term X also. Okay. So we are provided with 4 moles and 6 moles. Moles is given to us. So we don't
Yeah.
have to calculate the number of moles. Okay. It's already given. Just substitute in the mole fraction formula. So the mole fraction of the alcohol, which is XA, is equal to Na divided by Na plus Nb. Okay. A represents the alcohol and W represents the water. So 4 divided by 4 plus 6 is giving 0.4. So can you tell me the mole fraction for water? What is XW?
For water, it will be 6 by 10.
Yeah. Answer is
3 by 10, so it will be 0.3.
0.6. It is 0.
Yeah, 0.6.
Yeah. Just to avoid this type of mistakes, what you can do, I gave you that formula, right? Sum of the mole fraction. XA plus XB will be equal to 1. So you
One.
have got the value of XA. Okay.
0.4
Now we
plus
have to find out
0.6.
for XB. So what you need to do? XB is equal to 1 minus 0.4. That will give you 0.6. Getting?
Yeah,
Sum of the mole fraction should be equal to 1. 0.6 plus 0.4 will be equal to 1. Got it?
yeah,
So in some questions, you will not be provided with the direct number of moles values, like the 4 mole and 6 mole like this. So they will give you the mass of alcohol, like 4 gram of alcohol reacts, for alcohol means they will not give you as alcohol, 4 gram of ethanol reacts with mm, 16 gram of water. Okay. So like this information they'll give. So in this case, what you will do, you have to find out the number of moles to substitute here in the formula, right? So
yeah,
you have to use number of moles is equal to mass by molar mass formula. Suppose if I want to find out the number of moles of this component A, which is ethanol, C2H5OH, I will be substituting the mass of ethanol, which is 4 gram, divided by molar mass of ethanol. You know how to calculate the molar mass now? So I have 2
yeah,
carbon in the formula, so it will be 2 into 12, 24. And I have 6 hydrogen, so it is 6. And 1 oxygen, it is 16. So it will be 60, 46. So the molar mass is 46. Are you getting? So
yeah,
then I will get the number of moles. And in the same way, I have to find for water also. And for water, it will be NB. It is 16 gram. Molar mass of water, we know it is 16 by 18. So from this, I will get NB. Then I have to substitute here. Okay. I have to
yes,
substitute those values. Then I have to do the division, multiplication, everything. Clear?
yeah,
Yeah, I hope you have understood this. So shall I proceed with the third concentration term, which is
yeah.
molarity? Yes?
Nothing. I'll just copy down.
Okay.
Yeah,
Okay. The third term is molarity. So molarity is a very important term, concentration term among the others. Okay. So the definition of molarity says that it is the number of moles of solute present per liter of solution. And it is represented by capital M. Okay. And in terms of formula, molarity is equal to number of moles of solute divided by volume of solution in liter. Volume of solution in liter. That is very important. Volume of solution in liter. And the unit is mole per liter. So number of moles unit is mole. And for liter it is L, no? So if you take this to the numerator, it is mole per liter. Number
Yeah.
of solute divided by volume of solution in liter. Finished. Just write down the formula and unit alone.
Yeah.
Yeah. Now for dilute solutions. If I'm diluting the solution, diluting in the sense I'm going to add some water. So initially I have a container, okay, and I have the solvent and solute particles and everything is mixed, etc. Okay, and the molarity of the given solution is M1 and the volume of the solution is taken as V1. Now what I'm going to do, I'm going to add water. On adding water to this solution, the molarity of the solution and the volume of solution changes, right? Or it remains same? What is your answer? Will the molarity and volume changes or it remains same on addition of water to this?
No, it'll remain same.
No. If I'm
Number
adding,
of number of moles of solute present in per liter of
okay,
solution.
I'm asking you volume and the, okay, leave the molarity. Just tell me the volume alone. If I add water to the system, volume will change, right? So
Yeah.
initially, the volume may be 10 or 10 liter. And if I'm adding water to this, some more water to this, obviously it will change. If I add like 10 more or 20 liter of water, obviously the final volume will change, you know.
Yeah.
Yes, yes or no, Sujal? It will change or
Yes.
it will not change? It will
Yes,
change.
it'll change.
So you see, the volume is changing from V1 to V2. And the number of particles present inside that solution also changes. So, number of moles means molarity. Okay. So, molarity will also change from M1 to M2. So, here also I have only six particles, six or seven. Yeah, six. 1, 2, 3, 4, 5, 6. And here also I have 1, 2, 3, 4, 5, 6 only. Are you getting my point? So in
Yes.
the first case also I'm having six particles, okay, in which is present inside 10 liter, and here also the same 10 particles present inside the same 30 ml of 30 liter of water. Okay, so the number of particles remains same, but the volume changes. So what happens? Number of moles divided by volume is called as molarity. So volume is changing. So obviously molarity will change. So that's why M1 is also changing to M2. Able to
Yeah.
understand? Yeah. So for dilution of solution, M1 V1 will be equal to M2 V2. M1 V1 will be equal to M2 V2. Okay. So to understand this, we will solve some questions. So now I will solve one question for you from molarity concept. For
Yeah.
dilution
I
of
know
solution,
Tom.
M1 V1 will be equal to M2 V2. So write this alone.
V1 is volume, right?
Yeah, yeah. V1 is initial volume and V2 is final volume.
Yeah.
Next,
Yeah. Yeah. Done.
yeah. Calculate the molarity of aqueous NaOH solution prepared by dissolving 4 gram of NaOH in enough water to form 250 ml of the solution. So, by looking into the question, first thing you need to do is take down all the given values. Okay, so what are the values given to us in the question? So first of all, we need to calculate the molarity, that is understood. Of which compound? Of aqueous NaOH. Okay, the compound is sodium hydroxide, which is prepared by dissolving 4 gram of NaOH. So what is this? This is the mass, 4 gram. So it is the mass of the solute. Okay, in enough water to form 250 ml of the solution. So what is meant by ml? It is volume, right? So it
Yeah.
is volume of solution in terms of milliliter. So in the question, we are provided with the milliliter value only. So these two are the given values. And using these two, we have to find out the molarity of any unit. So how to proceed? What is the formula? What is the formula for molarity? Molarity is equal to number of moles of solute divided by volume of the solution in liter. We have only the mass, not the number of moles. So what we have to do? We have to find out the number of moles. You know how to find out the number of moles from the mass, right? Yes or no?
Yeah.
Yeah. How to find out? Number of moles is equal to
Given mass by molar
mass
mass.
divided by molar mass. Given mass is 4 gram. The molar mass of sodium hydroxide we can calculate. For sodium, I have given you the value. It is 23. And for oxygen, it is 16. And for hydrogen, it is 1. So if you add everything, you'll get 40. So 4 by 40 will give you 0.1 mole. Okay. So I'm having number of moles in my hand now. Now the next thing is volume. Volume in terms of liter. So just convert this milliliter to liter. How will you convert? You have to divide by the number 1000, no? 250
Yeah, yeah.
ml by 1000. So that will give you 0.25 liter. Now we have both. We have both the values in our hands. Just substitute in the molarity formula. Molarity is number of moles by volume. 0.1 divided by 0.25 will give us the answer, which is 0.4. Okay. Unit is very important. Mole per liter. Mole per liter.
Liter. Liter. Yeah.
Units are very important for physical chemistry. So before proceeding with the formula, just check with the units. If the masses is given in terms of kilogram, then you need to convert that to gram. Then only you have to proceed. Okay.
Yeah.
Are you done with this?
No, I'm copying.
Okay. Is your completed?
Yeah. Yeah.
Okay. So I'll give you one more question. Calculate the mass of sodium acetate required to make 500 ml of 0.375 molar aqueous solution. And the molar mass of sodium acetate is given as 82 gram per mole. Molar mass is given. We need to find out the mass of sodium acetate. And 500 ml is the volume. and 0.35375 is the molarity. So how will you proceed? So molarity is given to us and volume is also given to us. To convert the given volume, like 500 ml to liter, and it will be 0.5 liter. Okay. Substitute
Yeah.
in the molarity formula. Okay. Substitute in the molarity formula. So molarity is given to us, but we don't know the number of moles. So just keep number of moles in one side and bring everything to the other side and multiply and get the number of moles. Is it clear up to this? So what we
Yeah.
have got? Number of moles. So why I have calculated the number of moles? To find out the mass. To find out the mass. Because number of moles is equal to mass by molar mass. Okay. So to find out the mass, I need number of moles. So that's why I calculated the number of moles. So now substitute in this formula. Okay. In the mass formula. Substitute the mole values and molar mass. Molar mass is also given to us in the question. So number of moles into molar mass will give us the mass of CH3COO, which is sodium acetate. Okay, clear? Can you able
Yes.
to understand how to proceed?
Yeah, I understood.
Yeah. Vijay, are you done with the question?
Yeah, I have written.
You have written?
Yeah.
Okay. So the last term is molality. So I think I will discuss that in the next class. Okay. So molality, after completing this molality, I will do some previous years NEET questions and J mains level questions from this. Okay. J mains and NEET questions, they are more or less of same level. So I'll solve some of the questions, previous year's questions from this lesson. Okay, once I complete the modality. And after completing that, we can proceed with the next lesson. Okay.
Yeah. Thank you.
Okay, fine. If you're having any doubt, you can ask me. Otherwise, I'll wrap it up the session.
No, ma'am, I got it.
Okay. Thank you, Sajal. Thank you so much.
Yes, thank you, ma'am.
Yeah. Yeah, hello, sir. Shall I leave?